Hello and welcome to another lecture. There was a lot of question about this homework. How do we solve this problem? So here's the problem. Take a look at it on a board. The vehicle weighs about 2,000 kilogram, and because it's a 2,000 kilogram, we work in an SI system. It's not a pound. We got to convert this to a Newton to make it a force. We multiply by 9.8, 19,600 Newton. Okay, that's it. So the question want to know how much force was required to tow this vehicle, assuming the back wheel B are the brakes are locked in. So there's a lot of friction there, and the front wheel are free. Okay, so let's get to work here. First thing we're going to do our feedback diagram, and look at what I have on the board like we had previously before. We're going to lay out all the reaction. There's a reaction, we're going to call this Na. We could say 2 times Na, but or 2 times Nb, but we're going to go ahead and just say, assuming all the weight, it's an axle, and then we're going to use one load here. So this is going to be Na, Nb. You could do 2 Na, 2 Nb, then they cancel each other, so it'll be Na and B. Then this is a free, this wheel rotates, so there's no friction here. Then the force is going that way, so our friction force going the opposite way. And we're going to have F of B coming right here. So there it is. We have the reaction NB, reaction NA, the friction force F of B, and the force that is pulling it at 30 degree. And this is 0.3 meters from the bottom of the tire, and 0.75 from here to there, 1 meter from center of gravity. So this will be the center of gravity. And then we have 1.5 from this tire to the center of gravity. Okay, the first thing we're going to do, we're going to set up our sign convention, remember? Okay, X, Y, moment, positive. So X toward right is positive, Y going up is positive, rotation counterclockwise is positive. That's a sign convention we're going to use. You could use other ones, that's fine too, but let's go with this. Then we have a four equation here, and you know that. We always say summation moment is equal 0, counterclockwise is positive, summation f of y is equal 0, going up is positive, summation f of x is equal 0, going right is positive. Basically that's what we're saying. Because we have a friction, also the friction is equal, F is equal mu times N. In this case it will be mu times NB, and I think mu is a 0.3 here. All right, so I'm going to go ahead and take this one first, summation moment. I'm going to take a moment about either this point A or point B. That way you eliminate one of them. Because we're interested in this, we're going to take a moment about point A. Summation moment about point A is equal to 0. Counterclockwise is positive. So we're going to start from one end, work all the way this way. We have F. F has a 2 component, remember? And F has a vertical component, and that's a F of Y. And also has a horizontal component. Let's call it f of x. Each one of those take a moment about this point. So let's go to the f of x first. So that's going to rotate. It's going to rotate this way. And that's, see that? It's positive rotation. So the f of x part is going to be what? It's going to be f cosine 30. And multiply the distance that it's going to rotate is a 0.3 meter. Okay, then we have the y. The y component is going to rotate counterclockwise, clockwise. And that's going to be negative, so it's going to be fy, which become what? F of y, let's put the minus first. F, y is f times sine 30. Sine 30. And the distance is 0.75. And then we're going to come in here. This cannot take a moment by itself. The next force is right here, and that's going to rotate clockwise. So it's going to be minus 19,600, and that distance is 1. And then we have, then we're going to come in here, these two forces right here. NB is going to rotate positive plus NB time 1.5, 2.5 plus NB time 2.5. And this cannot take a moment about here because it's the same line of action, equals 0. So that is our equation 1. So that's the equation 1. Let's go for equation number 2. I'm going to use summation f of x is equal 0. Going to the right is positive. I have f minus f cosine 30. That's it. Nothing else here. Nothing there. Nothing there. Equal plus f of b. Plus f of b is equal 0. So we can simplify that. We can say f is equal, because we're interested at that, it's going to be f of b divided by cosine 30. That's equation number 2. All right, let's go for equation number 3. And that's a summation f of y is equal 0. Up is positive. Vertical component that become f sine 30. And then I have plus NA plus my NB and minus 19,600. And that's equals 0. That's equation number 3. Let's go for equation number 4. And that's right here. So f of b, the friction, is equal mu times N of b. This is the only tire that is locked in, has a friction. This is a free wheel. There's no friction there because it rotates. But this one, the brake is locked, so there's a friction force involved. So that would become 0.3 times NB. Therefore, our equation number 4 is going to be f of b is equal 0.3 NB. Equation number 4. Okay, you got 4 equations, and you got 1, 2, 3, 4 unknown. So we can solve it. You look at this, you say, okay, what am I looking for? I'm looking for f. So when I look at f right here, if f is f of b divided by cosine 30, so I got to find f of b. Then I'm going to come look at f of b. F of b is equal to 0.3 times n of b. So I got to find n of b. N of b is the key for here. Then we can go back and solve anything. So how do we do that? Take this equation, put it in there. So I'm going to say substitute equation 4 into equation 2. Okay, let's use a different color. These colors, they do not do good. Maybe this one is good. So I got f right there. I'm having an issue here. I got f right here. And instead of f of b, I'm going to put down 0.3b, 0.3 NB divided by cosine 30. So that's my f. If I do that out, it becomes basically, you can use a number. F is equal 0.346 N of b. That's what it comes out to be if you divide the 0.3 by cosine 30. Now take a look at equation 1 right here. We have f cosine 30, so I can put this number in there. F sine 30, I can put this number in there. And everything in terms of NB. So using equation 1, we're going to go ahead and substitute this in there. So instead of f, I'm going to put down, you could use this number, you could use this, look like it's easier to use this. Instead of f, I'm going to put down 0.3 NB divided by cosine 30 times cosine 30 times 0.3 meter. Okay, and then I have minus 0.3 NB divided by cosine 30 times sine 30 times 0.75. Okay, and then I have, I'm going to put that in first, and I'm going to put that one on the other side. So it's going to be plus 2.5 NB, and then I'm going to take 1900, put it on the other side, equal 1916 Newton. Okay, let's simplify this. Cosine 30 is going to cancel out, and sine 30 over cosine 30 become tangent 30, and then NB going to add up with each other. If you simplify this, it becomes basically 19,600 divided by 2.46. That's equal NB, which comes out to be, I got 7967, 7968 Newton. So now you have that, and you find NB. You're going to go ahead and put them in right F here. And our F going to come out to be 0.346 times 7968, and that's equal 2756 Newton. That's the answer right there. You can go ahead and substitute and find out NA, and that's it. That's only one left. So this was it, and subscribe and give it a thumbs up.